Thank you so much, Henry, for chairing this panel. I guess when we talk about the discussions in Token 2049, one thing that we wouldn't miss is perspective on ZK, some of the latest technology, as well as the talents in the fields that how should we actually continue to build them. So now we're going to present 3 of our proud portfolios, Hyper Oracle, Polyhedra, as well as we're also going to welcome
Yeah. I want to put down a technical alert here. This conversation is going to be very, very hardcore. And yeah, so just like don't hesitate to ask this genius question after the panel. So hi, yeah, let me introduce myself. And my name is Katin. I'm building a project called Hyper Oracle, which essentially is like a ZK Oracle protocol to scale a smart contract to enhance the smart contract computation ability, and it's like computation data source for their computation.
Hi everyone, my name is Jiaheng. I'm the co-founder and chief scientist in Polyhedra, and Polyhedra is the company, a startup company, building the cross-chain bridge with the technology of zero-knowledge proof. And I will also join National University of Singapore as assistant professor next month. So later on, I will also be here for a long term. So that's good to be Singapore. Thanks.
Hi, everyone. This is Sinka, and I'm the founder of Delphinus Lab. And currently, we are presenting a new ZK virtual machine that supports WebAssembly as an alternative to Ethereum bytecode. Thanks.
Yeah, so today's first question is, what part in blockchain we can use zero knowledge to scale it?
Okay, that's a great question. So the first one I have to say is a bridge, right? Because we are building the ZK bridge. So we're exactly using the technology for ZK to scale whatever the transactions, so massive processing token transfers in cross-chain bridges. I think it is pretty cool because if we want to secure an efficient bridge across different chains, in the concept we need to prove something like the consensus layer of the source chain. And it will relate you to the proof system. And it's also related to some complicated functions we need to prove with with ZKP, like the signature validation. We know signature is complicated, and if you have some basic knowledge about zero knowledge, most of them are based on circuit. So if you want to write some complicated function with circuit, it must be a very, very large circuit. And that means you have to some advanced proof system or some new method or algorithm of ZKP to do these things. And you have to do it very fast, and hopefully you can also bench these things all together. Then you can scale the transaction transfer or token transfer in bridge. Of course, another thing is I think it's the ZK drop. We just use the technology to generate proof, and others only to validate the proof on chain. And with this method, we can accelerate the transactions in Ethereum, and I think many companies are developing their ZK drop. So I think this is two points I can think right now about the scalability with ZK technology. Thanks.
Okay, cool. Yes, I'm actually a fan of your project anyway. Regarding my side, I think the pioneer in the blockchain has already made lots of work, made lots of contribution to actually make the blockchain security, right? And by actually leveraging the consensus algorithm to build a shared computer worldwide. But currently, what we are going to do is somehow improve not the security part, but also the programmability part. Eventually, we would like to have a style that the programmers can program their program in the generic way so that they cannot feel the difference when coding Web 2 programs and the Web 3 programs. Currently, if you want to write a contract, you have to write Solidity, right? Or you need to have some very weird compiler that transform the maybe C language or Python language to Solidity bytecode. And our approach is that we inject another layer, it's called a CK WebAssembly virtual machine, so that people can code in their program using the program language that they are familiar with and compile that to WebAssembly. And by running their program in the CK WebAssembly virtual machine, we connect the CK WebAssembly virtual machine with the Ethereum by submitting the proof that generated from the CK virtual machine. And I think this might generically improve the programmability for our blockchain programmers and somehow embrace a large audience to contribute to the Ethereum in the future. Thanks.
And your opinion?
Yeah, my opinion is definitely about like we can use zero knowledge proof to get more data source and more computation for the smart contract. And so I think the modularity should have like another kind of understanding at this moment. It's like about to get the blockchain to do some consensus job and let the Oracle to do like some data fetching and computation job, and let the let the storage to do storage job, and like also can use ZK Bridge to communicate between different blockchain and use ZK Wasm to and ZK VM to do some heavy compute that used to be pretty hard to be verifiable before. And we can also extend the variety of like how we make smart contract. We don't need to limit ourselves to only use Solidity for the Ethereum contract once we got a ZK Wasm there, right? And yeah, basically that's what I think. So right now I'm going to go this question deeper to a really, really interesting question that people right now is like fighting on Twitter about which scheme is the, like which commitment is better in ZKVM. Is it FRI better or the KZG is better?
Well, it's very interesting problem, and yeah, many people are fighting like which is better. I think it is hard to answer because you cannot say like one scheme is pretty good or like much better than the other. I think they have their advantages separately. Like for example, for the KZG problem, commitment is pretty simple and proof size is pretty short and it's linear homomorphic, and actually which is really good because if we want to generate proof, we hope it is simple, and we also want sometimes we, or like in general case, we also want to put the proof to the chain, and hopefully we hope the proof size is short and the gas cost is low. Then in this case, the KZG is pretty good. That's wonderful, right? But also it has some disadvantage. That's also a reason why people later on, find the FRI, because the KZG needs a trusted setup. It is contradictory with the decentralization and the trust minimized in blockchain, because we don't want the trusted third party. Then we just have a blockchain and decentralization and blah, blah, blah. So in this, to some extent, the KZG, the setup of KZG breaks the trust assumption. So we have FRI. FRI is good because it is transparent and it's plausible, post-quantum secure. It is pretty good, and it has some problem, right? In the original problem, the proof size is bigger, much bigger than KZG, and it is not pairing friendly. So if you put the proof directly on the chain, it is pretty big and the gas cost is unacceptable. That is bad. But right now, we also have some technology to do optimization for this method. We can try to do how to aggregate this thing, how to batch this proof, and how can we use like recursive proof to reduce the proof size. And I think I think there is a long path for the whatever in the industry and in the academia for the polynomial commitment. We still have many things. There are much room for us to do improvement. And we don't need to argue which one is better, but we can try to develop the better one, maybe the best one in the future. That's my opinion. Thanks.
Hi, I think this is really a complicated question. So to answer that, I would like to divide the application stack for the CK knowledge proofs into 3 parts. The first part is the most top layer. It's called arithmetic. And in between, there's something called the CK scheme, right? As far as I know, Divogo currently is the quickest CK scheme in the world, right? But even if that's the quickest, it's actually derived some idea from the second layer, the third layer, which is called the toolings of the CK, which contains the commitment, contains the sum check, contains the layered polynomial gates, right? So we are actually working on the arithmetic gate part while actually leave our commitment part and the schema part to Hello 2. And Polyhedra actually have their own proving schema while actually derived from the tooling set. It's a combination of the sum check and the layered gates. Okay, and as far as I know that if you want to actually get a very quick prover and you have a very good batcher to actually batch the stack proof into Snark, then currently FRI actually takes the lead, right? But if you're actually doing something like HyperOracle, right, actually building some oracles, would like to actually connect the data that from the Ethereum, while the Ethereum 4844 somehow utilizing the KDG commitment, and you like to have a very friendly connection with the KDG commitment of the data proof, then you probably can choose something like KDG and a little bit FRI to do the lookup, so which might lead up to something called a hybrid backend. But you probably can build another maybe scheme sooner or later, I'm not sure. So from my side, so it's not a yes or no question that because people can always build a scheme on top of the toolings with a hybrid commitment scheme. Thanks.
What's your?
Yeah, I think like the hybrid usage for different scheme in different situations will be a good conclusion here. And it's like, because when you talk about good and bad, I want to narrow down into the ZKVM case, because like in this certain case, we probably have a conclusion. But since we are still too early to put down a conclusion, like which one is better in ZKVM. And I want to go to my another question is that how in this industry, we know talent is the most important resources for projects and for industry. And do you guys have any secret way to bring up your team and find this talent and make them can hands on the project and make the circuit and stuff?
Okay, firstly, I want to see if I have a secret way. I don't want to make it public. But I can say something about the general way. Yes, it's very hard to find the talents, especially in the area of zero-knowledge proof or whatever in the ZKP research or engineering and engineering on the ZK circuit. It's pretty hard. So the first thing, I think we should go back to the education system. Maybe because we don't have enough candidates. Many students in universities, even in math department or computer science department, they don't learn cryptography and zero-knowledge proof. So if we want to have to recruit more talents, the first thing is that we should have more qualified candidates. And it depends on to the responsibility in the university. If we have a good course and if we have a good education system, more and more people are interested in this area and they can learn something and they can start to work on these things in during their study. That is pretty good because we know students are very smart. We have very talents in the top university in every country. And if they can provide us with these good candidates, that is good. But currently, if you force me to say something about the secret way to recruit people, because I'm an assistant professor, so I can post the ads to attract the students, and I work on this area. So these students must be interested in my research area, and they know some basic knowledge. So that is good. Maybe I can also ask them, do you want to do an internship or do you want to join the industry after graduation or whatever? And previously, I also did my PhD, and I also work on this area. That means I can attend some related conference, and I know people in this conference. So I know many people in this area, and I know their research area with more details, and maybe I also know their skills and their strengths. So this is good for me because I can just send an email to them. Okay, do you want to? Will you graduate soon, and do you consider joining our company, or at least would you like? Are you interested in some side event during the conference? So I think it is a good start for these companies to recruit new employees. Thank you.
Okay, thanks. It's talent acquisition. I currently do not find a routine way to actually acquire talents. So I think I probably do two things. The first thing is to actually keep explaining to talents that what we are doing actually makes sense, and they can get some kind of experience when working on a CK virtual machine project, and then when they actually move on to something more interesting, they get experience. I mean, and the second thing that we can do is to actually raise the salary, right? I have no choice. Thanks.
Yeah, thanks you guys to share your guys' knowledge and experience. Yeah, thanks you guys here.